then basically that is mobile phase going up. Then A is being distributed at a particular point of time. This A is being distributed. Some part of A is in the mobile phase, and some part of A is in the stationary phase, and there is an equilibrium between this. So that equilibrium is being studied over here. And this is the equilibrium constant. This is the equilibrium constant, that is Ka, that is the partition coefficient or distribution coefficient or partition ratio. This I was mentioning. And so this is the Ka, that is nothing but concentration of A in the stationary phase and by concentration of A in the mobile phase. Similarly, the particular component B, that is also at a particular point of time, and this B is also being partitioned between, distributed between some part of the B in the mobile phase, some part of the B in the stationary phase, and therefore the partition coefficient of B, KB, that is B in the stationary phase by B in the mobile phase. So Kb is concentration of B in the stationary phase, B in the stationary phase by B in the mobile phase. So in more technical term, we use partition coefficient, but the basic understanding that remains the same. That basic understanding of this Lord and Hardy interaction, differential interaction leading to differential migration. So this they are saying because Ka, because the interaction is not same, is not equal to Kb, and no two components can have same partition coefficient, and hence they will be separate. So it is very apt of saying that very apt of saying that chromatography. So it is very apt because sometimes this particular phrase that is being used, and so it's very apt of saying that chromatography is a process of separation. Chromatography is a process of separation of substances by differential migration. Chromatography is a process of separation of substances by differential migration, and the keyword being differential interaction of the components with the stationary and mobile phase is leading to differential migration, and that is leading to separation of components. So I will stop here in this lecture video. In the next lecture video, we'll try to discuss about the classification of the processes and some examples of chromatography. Thank you, dear students. I'm Dr. Sasi signing off. You take care of yourself and bye. So, dear students, I'm Dr. SRC. Now, let me focus on the classification of chromatographic processes. So, here we are going to focus on what are the different types of chromatography that are there and how they are being classified. So, let me go to the classification here. So, here the classification of chromatography are either based on the stationary phase, so that is the stationary phase, or in the eyes of stationary phase, how the chromatography can be classified, you can say that, or the mobile phase. So, with respect to the stationary phase, they can be classified, with respect to the mobile phase, they can be classified. So, let us take one by one. Let us take one by one, and the syllabus of an entire thing will also get clear from this classification. So, this classification, let us take with respect to stationary phase first. Now, let us focus with respect to stationary phase. So, this chromatographic methods with respect to stationary phase that can be divided into solid stationary phase. Whenever the stationary phase is selected is solid, then that particular chromatography is called adsorption because the solute is being absorbed on the skin, not absorbed. So that is the solute is being absorbed on the particular solid stationary phase. So that is adsorption chromatography. And if the stationary phase is liquid, that is liquid stationary phase. There cannot be gas stationary phase. gas cannot be stationary. Hence, there are two types with respect to stationary phase. One is solid and one is liquid. And the liquid stationary phase, there is a name to that, that is liquid supported on an inert material generally. You will see the paper chromatography and you will find that the paper was not the stationary phase. There was something else actually was the stationary phase. It was water in the pores of the filter paper that was acting as stationary phase. And the paper was only acting as an inert support, nothing else. I will come to that. Wait, I will come to that. Have patience. I will come to that. Now, this is the liquid stationary phase that is called the partition chromatography. So, there are, with respect to stationary phase, if the stationary phase is solid, that is adsorption chromatography. If the stationary phase is liquid, that is partition chromatography. Now, if the solid stationary phase, it can have the next branches of that gas mobile phase. Solid stationary phase, the mobile phase can be gas, or rather, if the mobile phase is gas, that is called gas chromatography. GC. Very, very important with respect to chemistry, with respect to the quantitative sense separation, because nowadays different industries, research, they are using gas chromatography because that is kind of instrumental chromatography and the efficiency is very high, time taken is very less, and so on. And it can be solid stationary phase and liquid mobile phase. So it can be liquid mobile phase, and the liquid mobile phase, you will see these chromatography processes later. It is column chromatography, thin layer chromatography, it is the TLC, and the ion exchange chromatography. So solid liquid. If someone asks you about give an example of solid liquid chromatography, so it's solid stationary phase and liquid mobile phase. So basically column chromatography, thin layer chromatography, ion exchange chromatography. Solid stationary phase, gas mobile phase, so gas chromatography. Now going to the liquid stationary phase, now liquid stationary phase and then gas mobile phase. So this is nothing but gas liquid, that is GLC, liquid stationary phase and solid mobile, liquid stationary phase and gas mobile phase, that is gas liquid chromatography. And liquid stationary phase and liquid mobile phase, you will see this, studying that paper was an inert support. You will see this in the paper chromatography discussion, that is paper chromatography, and that is high performance or high pressure liquid chromatography, and that is HPLC. So this is the basis of separation with respect to the stationary phase angle and dividing solid stationary phase, liquid stationary phase, then the subdivisions, and that is getting clear that what are the different types of chromatography there are and how they are being classified. Now let me classify with a reverse angle. See, let me make these points clear first before the classification with that particular reverse angle. A technique that uses solid as the stationary phase are called adsorption chromatography. I was studying this is solid stationary phase adsorption chromatography. And now this chromatography is based on the principle that different compounds in a mixture have different strengths of adsorption to the stationary phase. So different compounds in a mixture have different strengths of adsorption to the stationary phase. And the technique that uses liquid as the stationary phase are called partition chromatography. So that uses liquid as the stationary phase, that is partition chromatography. Now the partition chromatography is based on the principle that different compounds in the mixture have different values of partition or distribution coefficients in the two phase, that is liquid liquid or liquid gas system. So adsorption chromatography is generally based on the principle that different compounds in a mixture have different strengths of adsorption in the stationary phase, and the partition chromatography is based on the principle that different compounds in a mixture have different values of partition coefficient in the two-phase system. Now, let me focus in the reverse angle, and that is with respect to mobile phase. So this is the classification that is based with respect to mobile phase. The same chromatographic methods in the mobile phase, there can be liquid mobile phase and gas mobile phase, as the solid cannot be a mobile phase, so that is also a classification in two ways, either liquid mobile phase or gas mobile phase. When you classify this, or rather in this way, then the liquid is the liquid mobile phase that has a name, that is liquid chromatography, and gas mobile phase that has a general name, that is gas chromatography. Now the stationary phase. Now this is the stationary phase can be solid, and the stationary phase can be liquid. If the stationary phase cannot be gas, so that is solid and liquid. These are the two options. If the solid, that is adsorption chromatography. Whenever that is solid stationary phase adsorption, and whenever there is a liquid stationary phase, that is partition chromatography. Similarly, in the gas mobile phase, it's solid stationary phase, that is adsorption chromatography, and liquid stationary phase, that is partition. Examples of liquid solid. So that is the example. That is liquid. That is the stationary phase. That is the mobile phase and solid stationary phase. So examples of this area, and that is the liquid solid. Examples of liquid solid, and this is basically color chromatography, thin layer chromatography, ionics. And this everything will get clear when you read those chromatographic processes. And if that is liquid, then that is paper chromatography, high performance liquid chromatography, that is HPLC. In the gas mobile phase you are having, and solid stationary phase, that is basically that is nothing but gas solid chromatography. So that is gas solid chromatography, and gas mobile phase and liquid stationary phase, that is gas liquid chromatography. But you see these students that you need to choose one with respect to classification. Otherwise, the same thing being said in different ways may make the thing unnecessarily complicated. Hence, in the scientific community, what we do is that the classification is based on the stationary phase is generally called. That is the classification that was made with respect to the stationary phase. This is basically called. This is not that this is not allowed, not that this is not allowed, but this is not followed actually, because we need to follow uh, one one only type of classification. Just the terms you need to get clear: liquid mobile phase, liquid chromatography, and gas mobile phase. In general, that is gas chromatography. But we follow the number one, that is based on the stationary phase, and which we are going to follow, we are going to follow this. So for the particular of clarification, I am putting here again, and that is the classification of the chromatographic method. That is in terms of stationary phase, and in the stationary phase, suppose we have a stationary phase, that is solid stationary phase, and liquid stationary phase. Gas cannot be a stationary phase. Solid stationary phase adsorption, and liquid partition. And out of that, you have these branches, examples, and getting an entire idea about the entire particular processes. For example, solid and gas, that is gas solid chromatography, solid stationary phase, liquid mobile phase. You learn column, in layer chromatography, ion exchange chromatography, solid stationary phase, liquid mobile phase, and high performance or high pressure liquid chromatography, that is HPLC. You will also see that liquid stationary phase and liquid mobile phase, you will also see HPLC. This is a second different grade of HPLC. One grade of HPLC that uses solid stationary phase and liquid mobile phase, and that is solid liquid is an example. That is a different type of HPLC. And another type of HPLC is there that uses liquid stationary phase, liquid mobile phase, that is HPLC. When you learn HPLC, that will get clear. And liquid stationary phase, gas mobile phase, gas liquid chromatography, and liquid stationary phase, liquid mobile phase, that is the paper chromatography. Now, what we will do is that just I was doing the clarification or rather classification part. Until and unless you read all the chromatographic processes and come back to this table, then only it will become very clear. So I will now what I will do is that I will study with you a type of chromatography, and that is the paper chromatography, and that will eventually make the paper chromatography clear. And when we study the column and etc., those also will get clear. Thank you, dear students. I'm Dr. Asasi signing off from this part of the lecture video. You take care of yourself, and bye. So, dear students, I'm Dr. SRC. Now, let us focus on the paper chromatography, one specific type of chromatography. So, let us focus on the paper chromatography principle. So, let us see the principle of paper chromatography. First, the setup, and then the principle. You see, in paper chromatography, as I was telling about the stationary phase, in paper chromatography, the stationary phase is water. which is supported by paper. So I'm trying to draw this out so that you will basically understand much better. This is the filter paper. This is the filter paper. These are the pores in the filter paper by which the filtration actually takes place. So this, with respect to pore size, it has different name like Wattman number one, Wattman number 41, 42, and etc. So these are the pores in the filter paper. Very small, generally not visible to the naked eye. Now, what is happening is that some water molecules that are being adsorbed in this particular pores, and from the moisture it is coming, then evaporating out, and then again getting adsorbed over here. So this is basically the water. So these are the water that are basically they are trapped in the small pores. So, what is the stationary phase? That is the water that is trapped. Suppose a water that is trapped in a particular hole, that is the water is trapped there, and so that is the stationary phase, and that is not moving because that is trapped there. And basically, the paper that is basically was generally seen as the stationary phase initially actually was not actually is not acting as the stationary phase. It is basically acting as an inert support to the stationary phase water. So generally, it was first thought when we were discussing chromatography in my previous examples. Also, it was thought that the stationary was said that stationary phase was basically paper, but it was not. It was not the stationary phase. It was just the inert material, inert support, and the water that is trapped in the pores of the uh, paper that is acting as the stationary phase. The paper used actually is your Wattman number 1 on 41, a fine graded paper that contains 22% by weight of water. That contains in the pores 22% by weight of water. These water molecules constitute the stationary phase of paper chromatography. So these water molecules constitute the stationary phase of paper chromatography. This I was saying, and I explained with the diagram also. The mobile phase is generally a polar organic solvent and water mixture that can change from particular components to components. The main important thing is that the mobile phase should interact with the component. So nature of the component determines the nature of the mobile phase to be used. What is the purpose of using a mobile phase that does not interact at all with the component? I say suppose the component is polar, we have chosen a totally non-polar mobile phase. So what is happening is that the component standing and the mobile phase going, but they are not interacting. So the separation will not take place. It is in our hand to select the mobile phase, select the stationary phase, depending upon the nature of the component, so that there is some work. That is the main principle. We get it very clear. I need work. I need some progress, and that is the key to any process. So basically, now you can see that the PPC that is an example of nothing but a liquid chroma. Further, the components of the mixture have different values of partition coefficient. This I was telling because this is the A, that some part in the mobile phase and some part in the stationary phase. So interaction with the mobile stationary, and so there's a partition coefficient of A will come, and similarly partition coefficient of B will. So the difference in the partition coefficient, forms the basis of separating mixture of compounds using the paper chromatography. So the difference in the partition coefficient that forms the basis for the separating compound, or rather the mixture of compounds using the paper chromatography. Now, because this is based on the difference in the partition coefficient, so this is a kind of partition chromatography. The species is a kind of partition chromatography. During the development, as the mobile phase moves to the stationary phase, the compounds A and B gets partitioned between the two phases. Basically, what is happening is that the compound is getting, or rather the component is getting sandwiched. So this is the component, and that is getting sandwiched between, this is the mobile phase, this is the mobile phase, this is the component, this is the mobile phase, this is stationary phase, whatever, water and etc. And the component, this is A, this is in stationary phase, this is the mobile phase, So that is getting sandwiched between them and looking like this, some part of A in the mobile phase, some part of A in the stationary phase. So A is distributed, partition between the stationary and mobile phase, and because of the interaction of A with the stationary and mobile phase combined is different from interaction of B with the stationary and mobile phase combined, and so they get separated because of the differential interaction leading to differential migration. Now, this is to be noted that no two compounds can have exactly identical partition coefficient. I told you that they can be very similar, very similar. Values can be very close, but because the compounds are different, components are different, so they cannot have exactly same partition coefficient in a two-phase system. Now, for an example, actually, if we suppose that B is more soluble in the mobile phase than A, that is our supposition that if we suppose that B is more soluble in the mobile phase than A, and the other factors are more or less same. So in that supposition, and B is more soluble, and suppose we are learning this ascending chromatography, placing this paper, making this line, putting this spot, adding the components to be separated. This is A plus B, and this is the mobile phase there. And after the development, based on suppose the B is more soluble, moving much greater with the mobile phase. So B will be at the top, the solvent rising, if that is rising from bottom to top, ascending chromatography is, and A will look like this. Based on the supposition and other factors remaining same, so obviously B will be on the top and A will lagging behind. And therefore A and B will get separate. This is the case actually, this I was highlighting. This is the A plus B initial stage, and supposing B is more soluble in the mobile phase and other factors are more or less same, does this factor varies to some extent, and this is the solvent line. It is called the solvent front. Solvent has flying up to this particular, solvent is sliding over here, and by the capillary reaction, this is A and this is B, and B has migrated greater because of the solubility. Probably the mobile phase nature and the B nature matches, and therefore B is more soluble with respect to A. Other factors more or less same, so B is climbing up, and basically the separation is being achieved. So again, this holds. This holds. Interaction of the components. Interaction of the components with the stationary phase, with the mobile phase. Interaction of the components, that is A and B. That is interaction of the components A, B. Interaction, differential interaction leading to differential migration, differential interaction leading to differential migration, and that is leading to separation. So for the separation chemistry, chromatography is very important too. Let me show you some lab figures here. And this is basically, this is like, say suppose we are learning descending paper chromatography. This is the glass rod, and this is set up here. This is paper, this is a glass chamber where the solvent will be there, and this is the particular lid, and this is the paper, this is glass chamber, this is side view, this is front view, and now this is after development, and that is basically the solvent has, you see the arrow, solvent is going down, descending chromatography. This is the initial particular original spot over here, and this component A, this component B, and the solvent front has moved to D1 distance, and B has moved to D3, and A has moved to D2. By because the solvent is descending chromatography, solvent is falling with respect to gravity, and the B is going forward. Therefore, so I can say that B is interacting more with the mobile phase, and more with the mobile phase and less with the stationary phase, then A, then A. And in terms of A, if you see the A, because that is falling down and it's lagging behind. A is interacting more with the stationary phase and less with the mobile phase than B. So this is the descending, and this is the another type of paper chromatography possible, that is ascending paper chromatography. The ascending paper chromatography, basically what we are getting is that this basically this is going up. See the arrow, and that is moving up. So this is the setup there, and this is the solvent, this is the mobile phase, and this is the inert support. And here you are having this force, and this water is there at 22% by weight, and is acting as the stationary phase, and the mobile phase is pushing this particular component, and after some time after development you are seeing this B going up with the solvent going up now. And so you can say that A is interacting more with the stationary phase and less with the mobile phase, and because B has gone up and this is the solvent has gone to this level, and B, you can say that B is interacting more with the mobile phase and less with the stationary phase as compared to A. And this is called the development of the chromatogram. So now this will be very clear to you, the classification process of the chromatography, and this was the solid stationary phase, and this was adsorption chromatography, and liquid stationary phase is partition chromatography, and out of that, now what I'm highlighting is that about the paper chromatography, I think that is clear because it is the liquid stationary phase, and because the water inside the pores of the paper, and that is acting as stationary phase, so that is the liquid stationary phase. And the mobile phase, that was nothing but a solvent plus water mixture, and so it is an example of liquid chromatography. By this way the entire classification is being done, and so I hope this principle of paper chromatography is clear to you, and the next lecture videos will again see a different types of chromatographies applications. I think that this separation process, if you learn very carefully, this will be immensely helpful for your industrial work in the research and development sectors. Thank you, dear students. You take care of yourself, and bye.